Hello?
Yes, Saad, can you hear me?
Yes, I can hear you.
Okay. Let me check. Okay, so the whiteboard is open now. Okay, so can you see my whiteboard now?
Yes, I can see your
Okay,
whiteboard.
okay, okay. Um, okay, so yes. Okay, so yeah, let's start again. We were discussing about acid. Okay, so what are acids? Acids, I mean, everyone, acid is something which is a chemical. But which type of chemical is acid? We have a lot of acids, like we have something like, or forget about the acid. We have a lot of chemicals, like we have carbonates, we have sulfates, we have chlorides, we have bromides. So how do we know that the given thing is acid? How can we declare something as an acid? So keep in your mind, acid is that thing which can give you acid is that thing which can give you H plus ion when you are dissolving it into the water. Acid is keep in your mind, all the acids are aqueous. We don't have any acid in a I mean in there is no anything which is solid and we are calling it acid. No, all the acids are aqueous, but except one. There is one compound which is sulfur dioxide. I mean SO2. We have something which is called sulfur dioxide, means SO2. That is considered acidic gas, and this is the only substance which has acidic properties in a gaseous state. This is really, you can say that is really dangerous gas. Otherwise, all the acids in the world, they are aqueous in nature. HCl, we always use HCl as an acid. I mean, everyone knows that HCl is the commonest acid, but HCl, how can we call that HCl is the commonest acid? Or um, let me tell you, HCl, whenever we make HCl, that is in a gaseous form. HCl is always available in a gaseous form. HCl, that is always available in a gaseous form. And it is harmless in a gaseous form. It is not doing anything in a gaseous form. It is not showing its acidic properties in a gaseous form. But yes, when you are dissolving HCl into the water to make it aqueous, when you are making HCl aqueous, then it can show you its acidic properties. Then you can call that HCl as an acid. Now, let me tell you what are the acids. I mean, how would you know that the given compound is acid? All the acids are those substances which can give you H plus ion when you are dissolving them into the water. Any substance in the world is giving you H plus ion. Any substance in the world is giving you H plus ion. When you are dissolving it into the water, you can call it acid. So acids are those substances which can donate H plus ion in aqueous solution. Now let me tell you one thing. What is this H plus ion? This is the ion of hydrogen. Okay, this is the ion of hydrogen, but we always call H plus ion a proton. This is H plus ion, but we are not using this word in a syllabus. I mean, that's what I am saying right now, that acid are those substances which can give you H plus ion when you are dissolving them in acid. But there is a theory which we have to discuss, the Bronsted-Lowry theory. Bronsted-Lowry theory, that was a scientist, and he said acids are those substances which can give you proton when you dissolve them in water. But they are giving H plus ion. We just discussed. So let's see what is H plus ion. H plus ion is the ion of hydrogen. What is hydrogen? The simplest element. What hydrogen has in it? I mean, if you consider hydrogen atom, so hydrogen has, for example, inside the nucleus, hydrogen has 0 neutron, but hydrogen has only 1 proton. There is no any neutron in the hydrogen, but there is only 1 proton. And this is the lightest and the simplest element. So around hydrogen, there is only one electron in the shell. Around the hydrogen, there is only one shell, and that shell contain only one electron. So when you remove this electron from the hydrogen, so definitely, I mean, for example, right now I am removing this electron from the hydrogen. So you know very well this shell. This is the shell which is around the hydrogen nucleus. This shell is imaginary. When you are removing the electron, so the shell will be removed. When you are removing the electron, so the shell will be removed. So when you are removing the electron from the hydrogen, it will become positive hydrogen. Now see what positive hydrogen has in it. Only one proton. There is only one nucleus, and in that nucleus there is one proton, no neutron, no any other electron. So H positive, hydrogen positive, is also called proton because H positive doesn't have anything except the proton. Hydrogen has only two things in it, a proton and the electron. If you are removing electron, hydrogen will become H plus ion. And what H plus ion has in it? Nothing except one proton. So H plus ion is also called a proton. So whenever, proton is something which is fixed. You cannot donate proton. No, there is no any, I mean, every element can accept, can gain or donate electron. But there is no any element which could donate a proton. Number of proton cannot be changed. So when we are using word adding of proton, removing of proton, moving of protons, so means we are talking about H plus ion because H plus ion is actually a proton. Is it clear?
No, I'm a bit confused. So how do you determine if a substance is an acid?
All those compounds are acid which can give you proton. Let me show you. For example, HCl. Why I am calling HCl an acid? Why I am calling HCl an acid? So according to the theory, there is a theory which is called Bronsted-Lowry theory. So for example, this is HCl on the screen. Why I am calling this HCl an acid? Because it is following a theory. Because when you make this HCl an aqueous solution, I mean, when you are dissolving HCl in aqueous solution, it will dissociate into its ion and it will give you a proton. I mean, when you dissolve HCl into water, so there is something for the HCl that it will always dissociate into H plus ion and Cl negative ion. HCl is, you can say that HCl is a covalent compound. Whenever you dissolve HCl into the water, it will dissociate into its ion. It will give you H positive ion and Cl negative ion. So see, HCl is giving you H plus ion. It is giving you a proton. That's why HCl called acid. All those substances which are giving you H plus ion, when you are dissolving them in water, they are called acid. In other words, all those substances which are giving you H plus ion, all those substances which are giving you protons when you are dissolving them into water, so they are called acid. You can see HCl is giving you a proton. It is giving you H plus ion. We just discussed that H plus ion is simple, a proton, because H plus ion has only one proton in it. So H plus ion and the proton both are the same thing. And whenever you dissolve HCl into the water, HCl being a covalent compound, it will dissociate into its ion. Keep in your mind, HCl will not dissociate like this, H and Cl. I mean, you will not get what is that called, neutral hydrogen and neutral chlorine, because chlorine is more powerful, more electronegative. So when you are dissolving HCl into the water, so water is more powerful, it will try to break HCl molecule. Chlorine is more electronegative, it will take electron of the hydrogen away from it. It will become negative and hydrogen will become positive, and positive hydrogen doesn't have anything in it. So the positive hydrogen is called a proton. So you can see HCl is giving you a proton. HCl is giving you H plus ion. H plus ion is a proton. That's why HCl is called acid. All the acids can give you proton. I mean, all the acids can give you H plus ion when you are dissolving them into water. You can select any acid. For example, HNO3. HNO3 is That is also one of the commonest acid. This is called nitric acid, HNO3. It will also give you, for example, we are dissolving it into the water, means we are making it aqueous. So when you are dissolving HNO3 in water, it will dissociate into its ion. It will break into its ion. What ions you will get? One H plus. H plus will be separated. H plus can be separated very easily. Hydrogen is weakest thing, lightest thing. And on the other hand, we have nitrate, NO3. NO3 is,
Wait,
NO3.
so if hydrogen has a positive charge, then it's acid, but if hydrogen has a negative charge, it's a base.
Yes, you are very close. But for the bases, we have to discuss OH ion. But hydrogen will not be having a negative ion. For the base, we have to discuss OH ion. So all
Okay.
the acids, anything can be considered as acid, which is giving proton, which is giving H plus ion when you are dissolving in water. Keep in your mind, we are dissolving it water. We are not reacting it with water. We are not reacting it with any other thing. For example, if you say we have Na2S, that is called nitrogen sulfide. And oh no, let's select some compound of hydrogen. For example, Na yes, NaH. NaH is sodium hydride. For example, when you dissolve sodium hydride into water, it will not give you H plus ion. See, this is sodium, and that is hydrogen, metal and non-metal, ionic compound. And ionic compounds are more stronger. You cannot break ionic compounds easily. So you will not get anything here. So, and keep in your mind, this is an ionic compound. So this is not acid because it will not dissociate into its ion. It will not give you H plus ion or something. But HNO3, all non-metals. So HNO3 will dissociate into H plus ion and a nitrate ion. Why the whole nitrate ion is separated? Nitrogen and oxygen both are more electronegative, more powerful. They have more nuclear charge as compared to hydrogen. They can be separated easily. And hydrogen is being a weakest thing, it will be separated from the nitrate ion. It is positive here. I mean, its electron has been taken away by the nitrate ion. So this HNO3, when you are dissolving HNO3 in water, it is giving you H plus ion. So HNO3 is an acid. For example, let's do one last example. For example, the most common is acid H2SO4, sulfuric acid. This is the most commonest acid which we are using in organic chemistry and in inorganic both. This is H2SO4. So H2SO4, why I'm calling it acid? Because when you are making H2SO4 aqueous, what does it mean? Means when you are dissolving H2SO4 in water, it will give you H plus ion and it will give you sulfate negative ion. Sulfate has -2 charge. Sulfate has -2 charge, means the valency of the sulfate is -2. So see, H2SO4 is dissociating into its ion when you are dissolving it into the water. Keep in your mind that we are discussing about making something aqueous. For example, if I'm reacting NaH with something and that is giving me H plus ion, so we cannot call it acid. We have to check. I mean, everything is acid when it is giving H plus ion when you are dissolving it into the water, not reacting it with something. If you are reacting HCl with something and it is giving you H plus ion, so we don't have to discuss that this is acid because it is giving H plus ion during the reaction. No. If it is giving you H plus ion when you're dissolving it water, this is an acid. Every acid will give you H plus ion when you are dissolving it into the water, either the stronger acid or the weaker acid. Both will give you H plus ion. Okay. Then what are the bases? So what is Bronsted-Lowry theory? Bronsted-Lowry theory is the theory, that was a scientist, and he said all the acids are proton donor. What does it mean? I mean, when you dissolve acid into the water, they will give you proton. They will give you H plus ion. So what are bases? For the bases, what are the bases? Bases are also called alkali. Bases are also called alkali. So what are bases or alkali? Both are the same thing, no? We have two names for the same substance, base and alkali. Both are the same thing. Okay, there is little difference, but the difference is not included in your syllabus. But let me tell you, all the bases which can be dissolved into the water, we call them base, or if they are not getting dissolved into the water, we call them alkaline or something. You don't have to go in that much detail. At your level or in your syllabus, base and alkali both are the same thing. I mean, there are two names for the same substance. Now, what is the base? Opposite to the acid. So for the base, we have two definitions because we have different type of base. I mean, every acid has H plus ion. This is so simple. Every acid has H plus ion. But we have two types of bases. We have hydroxide bases. We have oxide bases. And we discussed that we have one weaker base, which is ammonia, NH3. This is neither hydroxide nor oxide. Ammonia is, ammonia is totally different, NH3. This is neither hydroxide nor oxide. Then for the bases, we have different theory. So what is a base? Base is proton acceptor. If any substance is accepting a proton, what is proton? Proton is actually H plus ion. So if any base accepting H plus ion when you are dissolving it in water, acid is that substance which is giving you proton when you are dissolving it into the water. And what is a base? Which will accept that proton donated by the hydrogen. So base is proton acceptor, but we have one more definition because we have different type of bases. No? We have NH3, we have hydroxides, we have oxides. So for the bases, we have two definition. Either check that the substance is accepting the proton, means it is accepting the H plus ion, or the base could be any substance which can donate OH negative ion, which can donate OH negative ion when you are dissolving it into the water. Acid, proton donor. Acid, proton donor. Proton donor means they are donating H plus ion when you are dissolving it into the water. Bases are those things which are accepting that proton, or they are donating OH negative ion. So if any substance is accepting a proton, that is a base. Or if any substance is donating OH negative ion, that is a base. We have different type of base. For example, ammonia. Why ammonia is base? I mean, there was a confusion when we discovered ammonia. So there was a confusion. Most of the scientists said that ammonia is not a base. Reason? Because ammonia is neither hydroxide and nor the oxide. Because all the bases are either hydroxide or the oxide. Ammonia, not hydroxide. This is not oxide also. This is hydride, not hydroxide. It doesn't have OH. It is not oxide. And we know that all the oxides and hydroxides are the bases. So how can we say that ammonia is a base? Because it was following one of the definition. When you dissolve ammonia into the water, water is made up of H plus and OH negative ion. So when you dissolve ammonia into the water, so what happened actually? Ammonia is accepting the H plus ion from the water. Ammonia, you can say ammonia is breaking the water. This is the easiest concept. I mean, you can say that ammonia is breaking the water molecule and it is accepting the H plus ion from the water, and it is becoming NH4. After accepting H plus ion, it is becoming NH4 positive. So we just checked that ammonia is accepting H plus ion from the water. It means that is a base. You can say, I mean, ammonia is different type of base. So when we dissolve ammonia into the water, it was accepting H plus ion from the water. It is accepting the proton. So that is a base. That's what we discussed. Acid are proton donor, bases are proton acceptor, or bases could be hydroxide ion donor. So here, ammonia is accepting H plus ion from the water. That's why we say that ammonia is a base. This is the weakest base, and this is the only base which is having its basic properties in a gaseous medium. Ammonia is a basic gas, like sulfur dioxide is an acidic gas, SO2, sulfur dioxide.
Can you
But
explain bases again? Because I'm still a bit confused.
uh, in what thing? I mean, what is the confusion here? Acid and the base?
So no, so I get the acid. So I get that if hydrogen is positive, then it's an acid. But you said something with the OH. So I know hydrogen is negative, right? But how do you determine if it's a base?
Wait, um, wait. I got your I got your question. See, all the acids are proton donor, means they will donate proton, and this is the simple story. I mean, if you have HCl, so it is donating you H plus ion, so this is acid, and the story end. What about the base? Actually, the issue is with the base. I mean, the most complex thing is a base. What is base? For the base, we have two theories, or we have two parameter by which you can determine the given substance is a base. Either it should accept proton from anywhere, from anywhere. Base is something which can accept proton. Acid is something which can donate proton. Acid is something which is giving you H plus ion. Base is something which is accepting H plus ion, that is adding H plus ion in it. Or base is something which is giving OH ion. So ammonia is a base. Ammonia is a base because it is accepting H plus ion. Ammonia is NH3, and when you dissolve ammonia into the water, so it breaks the water into H plus and OH negative, and then ammonia accept this H plus ion from the water, and it will become NH4. That's why we call ammonia a base. And for example, if you have there is one more base, the NaOH. Why I am saying that NaOH is a base? Why I'm saying that NaOH is a base? Because when you make NaOH aqueous, means when you dissolve NaOH into the water, so this NaOH will dissociate into Na and OH negative ions. See, it is dissociating into ions, means it is donating OH negative ion. That is a base. And ammonia is breaking water and it is accepting H plus ion from the water. That's why ammonia is a base. So these are the bases. I mean, bases are something which can accept H plus ion from anywhere, or which can donate OH negative ion from itself. That is a base. Is it clear to you now?
Yes.
Okay. So let's recall it, then we can move. What is acid? Acid is something which is giving you H plus ion. And what are the bases, or what are the alkali? Bases are those substances which can accept H plus ion from anywhere, especially from the water. I mean, what acid we're doing? HCl is an acid, because when you are dissolving HCl into the water, it is donating H plus ion to the water molecule. Definitely, you are dissolving HCl into the water. So basically, HCl is also giving chlorine ion also. But we have to focus on hydride. I mean, we have to focus on the proton and the hydroxide only. We don't have to do anything with the sodium ion, with the chlorine ion. No. If you want to check the given thing in acid, you have to focus on the proton and the hydroxide stuff. So HCl is an acid because when you are dissolving HCl into the water, it is giving H plus ion to water. It is giving H plus ion to water. And why ammonia is a base? Because when you are dissolving ammonia into the water to make it aqueous, it is dissociating water, and then it is accepting H plus ion from water to become NH4 positive. Acid donating proton to the water, base accepting proton from the water. But we have one more thing. that is NaOH. NaOH is, this is the stronger base, this one. NaOH is considered as a stronger base. And why we are calling it base? It cannot accept H plus ion. This is impossible for NaOH to accept H plus ion. It cannot accept H plus ion. Then why we are calling it base? Because when you dissolve NaOH into the water, it will donate OH negative ion to the water. I mean, when you dissolve NaOH into the water, it will dissociate into sodium ion and OH negative ion. And you are dissolving it into the water, na? You are making it aqueous. So that OH ion, which is where NaOH donating OH negative ion to the water. So you can say that base is something which gives OH ion to the water. So C, sodium hydroxide is a base because it is donating hydroxide ion to the water. Ammonia, NH3, is a base because that is accepting H plus ion from the water. For the bases, we have two things now. But acid is something which can donate H plus ion to the water. And the thing which we are doing here, for example, we are using HCl. We are dissolving HCl into the water and it is broken down into H positive and Cl negative. So this is called dissociation. This is called dissociation. When you are dissolving HCl into the water, it is dissociating into its ion. And again, most of the students ask me that, Miss, why HCl is dissociating into its ion? Why it is broken down into H positive and Cl negative ion? Why you are not getting neutral hydrogen and neutral chlorine? So there is only one answer. And the answer is HCl is a polar compound, means chlorine is more electronegative, more powerful, more nuclear charged. So when forces inside the water are trying to break HCl molecule, and when the forces of water are trying to dissociate HCl molecule, so chlorine, being a more electronegative, will take away the electron of the hydrogen. So chlorine will be negative and hydrogen will be positive. And this will happen in every mineral acid. For example, HNO3, H2SO4. Hydrogen, we have to separate hydrogen all the time. Hydrogen is weaker than all the element in the periodic table. So you can compare hydrogen with any element. It is weaker than every element. So every element, every group of ion, every ion can, or anything can take away electron from the hydrogen to make it a proton, to make it H positive. So this is all about acid and the bases. So acid are those substances which can donate proton when you are dissolving them into the water. Base is something, base or alkalis are something which can accept proton from the water, because acids are donating proton to the water, so bases can accept proton from the water. Or if they cannot accept proton, so they should donate hydroxide ion to the water. Hydroxide ion is also considered as electron thing, but we never call it electron. Reason, H plus ion has only one proton, so we can call H plus ion a proton. We cannot call OH negative ion an electron, because it is having a lot of electrons. It has excess of electron, but it is having a lot of electrons. Oxygen, there is oxygen, it has 6 electrons. So we always call OH negative ion as hydroxide ion. Now, there is one more thing. How do you know that the given acid is a stronger acid? And how do you know that the given acid is a weaker acid? It depends. Basically, again, for example, we have HCl, and we just discussed that whenever you are dissolving acid into the water, whenever you are trying to make acid an aqueous, so it will dissociate into its ion. We have to use word dissociation. This is not something like broken down. No, this is the dissociation. Acid is giving you some ions. when you are dissolving acid into the water, it is giving you some ions to show its acidity. Okay. Okay, that's what you have to remember. See, acid is something which is giving you some ions when you are dissolving it into the water, especially that is giving you a proton, H positive ion. It means if you have any acid from the world, and when you're dissolving that acid into the water, it will give you ions. Okay. Why it is giving you ions? To show its acidity. Base will also dissociate into its ion to show its basicity. But we are discussing the acid now. Okay. So what is acid? Acid is something which is dissociating into ions when you are dissolving it into the water. Why it is dissociating into its ion? Because simple, to show its acidity. Okay, means acid is showing its acidity by dissociating into its ion. So if there is any acid, for example, we are dissolving an acid into the water, and we are dissolving, for example, 100 molecules of acid into the water. For example, we are dissolving 100 molecules of acid into the water. So these 100 molecules of HCl will dissociate into H positive and Cl negative ion. Why? To show its acidity. So if the ions, or simple, if the acid is more stronger, so it will show its more acidity. If acid is not stronger, it will show its less acidity. This is the easiest concept by which you could understand this stuff. I mean, I just said HCl is an acid and it is dissociating into its ion. Why it is dissociating into its ion? To show its acidity. So if there is a stronger acid, it will show its more acidity by dissociating into more ions. If there is any acid which is the weaker acid, it will show its weak acidity by dissociating into less ion. Because we just discussed that acid is showing you its acidity by dissociating itself into its ion. So if acid is showing you more acidity, it means that is more stronger acid. This is the easiest way by which you could understand this. If acid is showing you more acidity, how can acid show you more acidity? By dissociating into more ions, it means the acid is stronger. If acid is showing you less acidity, what does it mean? Less acidity means it will dissociate into less ions. So you will say, Miss, acid is showing less acidity right now. It is weaker acid. So this is very simple. If there is any acid, this is a theoretical thing. You cannot do it practically right now. This is a theoretical thing. So chemistry says if the acid is weak, so when you are, how do you know that the given acid is weak? It will show its less acidity by dissociating into less ion. If the given acid is more stronger, it will dissociate into more ion. So see, we are using 100 molecules of HCl here. So if all these 100 molecules are dissociating into ions, means you are getting 100 H positive and 100 Cl negative ions. So what is, I mean, there are 100 molecules of HCl. So you should get 100 H positive ion and you should get 100 Cl negative ion. It means if I'm getting 100 H positive ion and 100 Cl negative ion, it means all the molecules of acid have been dissociated into ions, means I am getting more ions, means acid is showing its more acidity. So the given acid is stronger. This is theoretical thing. So the given acid is stronger. But for example, HCl is a stronger acid. Everyone knows that acid is a strong, HCl is a stronger acid. But let's suppose for a single minute that HCl is a weak acid. For example, if HCl is a weak acid, so what will happen here? If you are using 100 molecule of HCl If you are using 100 molecules of HCl, so what will happen? When you are dissolving HCl into the water, so you can say, for example, I am getting 50, for example, I'm getting 50, 50 ions of H positive, and I am getting 50 ions of chlorine negative, for example. I mean, again, HCl is a stronger acid. But let's suppose that if I am dissolving HCl into the water and it is giving me 50 H plus ion and 50 Cl negative ion, but I know that I'm using 100 molecules of HCl. So if I have 100 molecules of HCl, so I should get 100 H positive ion and 100 Cl negative ion, but I'm getting 50 H positive, 50 Cl negative. It means only few molecules are dissociated into its ion. In other words, acid is not showing its more acidity right now because that is not a stronger acid. What is acidity? The power of acid. Right now, acid is not showing its acidity, means acid is not showing its power. It means the acid is not powerful, means the acid is the weak acid. The given acid is the weak acid. HCl is stronger. I just given an example with HCl. So this is how we can recognize the given acid is a stronger and the weaker. I mean, this is how we recognized that the given acid is a stronger and this one is the weaker. And this is how we make a list that HCl is the stronger. Why we are calling HCl is stronger? Because when we dissolve HCl into the water, it dissociated into its ion fully. It showed a lot of acidity. It showed it power. So we know, okay, so the given acid is powerful. But for example, let's select a weaker acid. For example, HCN. HCN is organic acid. This is just for the example. HCN is a weaker acid, hydrogen cyanide. This is a weak acid. How do I know that HCN, the hydrogen cyanide, is weak acid? Because when we did research work on HCN to check its acidity, I mean, we know this is acid. I mean, how do we know that HCN is an acid? Because when we dissolve it into the water, it had given us a proton and a cyanide ion. Means it has, when you dissolve it into the water, it has given you H positive ion and Cn negative ion. So it was giving you a proton, H plus ion. So I know that this is an acid. But on further research, we just checked that if we are using, for example, 1,000 molecules of HCN, so we are getting only 10 molecules of H positive ion and 10 ions of Cn negative, not the molecule, these are the ions. For example, I am using 1,000 molecules of HCl, but when I am dissolving HCN into the water, I am getting only 10 H positive ion and 10 Cn negative ion. What does it mean? HCN is not fully dissociating into its ion, means it is not showing me its full acidity, means it is not showing its full power. Why? Because it is not powerful. This is the weak acid. This is how you can say that the given acid is a weak acid or the given acid is a stronger acid. So all those acids are considered as stronger acids which can fully dissociate into its ion. Those acids are called stronger acid. This is how we declare H2SO4, HCl, and HNO3 as a stronger acid. But all those acids are weaker acids which are not dissociating into its ion fully. And we call them weak acid because they are partially dissociating into ions. Means they are not showing their full acidity. Means they are not showing you their full power because they are not powerful. HCl is more powerful. That is showing its full power by dissociating into all ions fully, not